What's up, guys? So today we've got something a little different as usual. We've got a van that has what appears to be a fuel pump issue. Came in not running. They said it sputtered and died. Now it won't restart. They killed the battery. They did a few other odds and ends to it, and they dinged up something else as well in the process. But I'm going to give you guys a little bit of a lesson on electrical troubleshooting, because it can save you a ton of time when you're working on vehicles. And if you're working on vehicles in any way, shape, or form on a regular basis, even if it's just for a hobby, you should probably have some electrical knowledge, because it is key when troubleshooting issues. I know a lot of people complain about having parts changed out and getting charged tons and tons of money for parts that didn't fix a problem, that all turned out to be a broken wire or something of that nature. But basically what we have is your typical Chevrolet van. It's a 3500 series with a 6-liter in it. Now we went back underneath, and this one's kind of an interesting project because it's a box van, so it's got a little bit of a difficult area around the gas tank to try and get the fuel pump in and out. You got to drop that whole tank back there, and it's got this big box on top, so it's a real big pain in the butt to do anything with it. So what we ended up doing was testing all of the electrical systems that pertain to the fuel pump. So we started up here in the engine compartment and tested with a power probe the relay for the fuel pump. Now the relay for the fuel pump checked out to be good, so we then energized the fuel pump wiring, and the fuel pump did not activate. So with the fuel pump not activating, went back to the back side of the truck, and right at the connector, hit it with the power probe again, hit it with 12 volts, the pump still wasn't going. Pulled the connector and found that a wire in the connector had rotted. So what was originally thought to be a fuel pump issue turned out to be a wiring issue. The fuel pump was totally fine. It was actually the wiring that was bad. So today what we're going to do is I'm going to go over relays with you guys, and I'm going to show you how they work, how you can jump them to test an electrical circuit so that you're not chasing things around and replacing parts that don't need to be replaced. This fuel pump for this van is literally over $400. So to not have to replace that pump and it just be a wiring issue saved this customer a ton of money, saved me a ton of time, and saved me from having to pull the fuel tank out of this thing, which of course once it doesn't run, they think it's out of gas, they fill the tank completely full, and you're doing a fuel pump in a fuel tank that is full of 55 gallons of gasoline at this point. So we saved ourselves. But I'm going to go over that now. So what I'll do is I'll take you guys down, and I'm going to actually show you how a relay works. I'm going to show you how you can jump a relay to test an electrical circuit, and yeah, we'll get to it. Alright guys, now that we got that van out of here, interesting story. We actually found 3 separate breaks in the fuel pump wiring harness. We also found that it had shorted to the gas tank when the wire broke, which in turn damaged the fuel pump relay and also damaged the main ECU relay, as well as blew the fuel pump fuse. So huge amount of electrical problems for that truck, and to be totally honest with you, a lot of places would have literally just replaced the fuel pump, replaced the fuel pump connector, sent the truck on its way, to which it would have, if it even started, would have lasted about a week or two, and then it would have died and would have been in the same situation again. So the importance of knowing the electrical systems on these vehicles, you can't deny. You really need to know the electrical stuff, especially on the new vehicles that are so electrical heavy and electronic heavy. It is imperative that you know it, because we literally got away without having to replace a $700 or $800 fuel pump. The bill was still not cheap, but at the same point in time, we did not have to add to it with that, you know, massive cost of the fuel pump. So what I'm going to do now is I have an actual automotive relay right here. I have my power probe right here, and I have a voltmeter, a fluke voltmeter. And what we're going to do is we're basically going to go over the operation of a relay and how it works. So I'm going to flip the camera around, I'm going to bring you guys down, and I'm going to try to do this in a way that you can actually see every bit of this relay, so that you know exactly how they work, so when you're troubleshooting your car, you'll be able to actually troubleshoot these relays and see whether or not it's a bad relay, because a lot of times there are cars that have known issues with bad relays, and we'll go over those a little bit more. So we're going to flip it, we're going to take it down to the table, and I'll show you guys this this setup. Alright guys, so here is your typical automotive relay. 4 pins, some are 5 pins, and we'll go over why in a minute. But your typical automotive relay, you've got a diagram of how the relay works and what pins are what. You have, you know, your basic number of the relay. This one is a ++0407, so it's just a generic. And then you have all your numbers here. This one is manufactured by Tyco, and there's a part number and everything else, so if you need to reorder this. But this is what 90% of your automotive relays are going to look like. Now there's some others, like Nissan uses a funky setup where their pins are different, and they have different color relays for different items in the car, but still basically the same thing. You have a part number. You also have a diagram of how the relay works right here, and they're all going to work exactly the same. Now, what is a relay? A relay is nothing more than an electrically activated switch. And the reason for a relay is basically, if you've got something like, let's just say your fuel pump or your radiator fans or your starter for that matter, there's a lot of current that is needed by that particular device that cannot be provided by a small switch, such as like the switch on your stalk for your headlights, the switch for your windshield wipers, the on-off for your cooling fans, things of that nature. So most of your automotive switches are only capable of handling 1 or 2 amps, maybe at the most, whereas these relays are capable of handling anywhere from 10 to 40 amps. So when you've got, you know, a radiator fan that's drawing 15 amps, if you were to switch that with a normal everyday switch, you would burn that switch up every single time. Same goes for your power windows. If you were to try to switch a power window with the actual window switch controlling the motor, you would burn up window switches every time you moved your windows. So that's what these are used for. These utilize a switch to come in, you activate a switch, it activates this switch, which can handle a much higher current than a regular average switch. This allows you to do that, and there are tons of them in these newer cars. So we're going to get into what all this stuff is and what's inside this, but I want to first show you the pin configuration on these. Now, yeah, you can actually see that. All right, so let's flip it this way. So now on this relay, this is a 4-pin relay. You see you have pin 85, 86, 30, and 87. Now, we'll get into this when we get inside the relay, but pins 85 and 86 are going to be your low current input pins. Pins 87 and 30 are going to be your high current switched pins. And we'll show you why that is and why these pins are offset like this and why these are straight. But if you look at the diagram of how this relay works, you can see here that there's the symbol for a coil. Then you have pin 85 and pin 86 supplying that magnetic coil. Then you have 87 and 30 have the symbol for a switch. Now if you look at this switch in line with the coil, what happens when you activate a relay is you put plus 12 volts on 85 and you ground pin 86. It creates a magnetic field in this coil, and it pulls this high current switch down and closes the switch so that you now have a connection between 87 and 30. That is literally how simple this is. It is nothing more than an electromagnetic switch with an electromagnet that energizes when you energize pins 85 and 86. It pulls this switch down, it connects 87 and 30, and there's your high current switching. So you only have to put about 20 milliamps into this coil to get it to activate, and you can actually switch 40 amps with these outer switches here, and I'll show you why in a second. So those are your pin configurations. So a lot of times what will happen is, let's just say pin 30 and pin 85 have plus 12 volts. Pin 86 goes to a negative trigger on your ECU. Let's just say for cooling fans. And then pin 87 goes out to your cooling fans. So you have positive, positive, negative switched from your ECU and your actual cooling fan. The other end of your cooling fan would be grounded. So when your ECU senses that the engine has reached, let's just say 210 degrees, the ECU sends a ground signal to this coil, which already has a positive leg over here. It energizes this coil, it pulls this switch down, and it turns on your fan. That is the simplicity of this switch. I mean, there's really not a whole lot going on here. But they are, I know, for a lot of people, it's a subject that's kind of like, oh my God, how do those work? I have no idea what these are, you know, how to troubleshoot them or whatever. So now we're going to pull this apart and actually see what's inside a relay. So there's that coil that was listed on the outside. Now you have some wiring in here. It's going to be very hard to focus on all this stuff. But if you notice, this is like pin 85 here. It runs all the way up and right to here, which is one of the legs for this coil. Then pin 86, which is over here, has another leg that runs up to this side of the coil. So those are the two that energize this coil. Now when that coil energizes, it creates a magnetic field and it pulls, let's see if we can get that in really good focus, it pulls the switch down. You see that little bit of movement there? That's literally it. It pulls down on that switch, thus making contact right there. You can see that contactor right there. Boom, switches on, switches off. Now, you notice how big and fat this wiring is here. This happens to be a 40 amp relay. So you can see how much girth is in that wire compared to the actual coil side. So now you have all these big beefy copper contacts. You have this big beefy copper wire. So when this comes down, it connects 30 and 87 together. And you can see this wire runs down, runs all the way over here and right to pin 30. So that's literally all it does. Magnetic comes on, boom, does that. So now what we're going to do is I'm going to set things up. We're going to come back, we're going to hook this up to a battery, and we're going to hook this up to the meter, and we're actually going to show you how this functions when you hook it up to a positive 12 volts. So we'll be right back with that. So here's the setup. We've got our relay, we've got our battery, we've got our mock ECU, aka the power probe. We've got the power probe connected to pins 85 and 86 on the relay so that we can switch it. We've got our meter set up to 87 and 30 so we can see the actual switching happening. And I'm going to bring the relay up close to you guys so that you can see the action when we actually activate the ECU. Now we're going to assume that our car's temperature is up to 210 degrees. The ECU says, hey, I need fan, I need cooling. The ECU sends a signal to pin 85 or 86 on the relay. The relay then closes the switch for our cooling fan, which we subbed in with our meter. So let's show you guys that now. So here's the relay. I'll try to get the best angle so you can see this. Hopefully it stays in focus. Alright, now our car hits 210 degrees, we need fan. See that switching? So if I could bring this a little closer, watch my finger down here. There we go. Anytime this switch closes, it turns our fan on. So we could even actuate it by hand. And you can hear the beeping. So now, failure points on these relays. There are two main failure points on these relays. The number one failure point are these contacts right here. Anytime you're activating a motor with a relay, so for instance, a fuel pump, a fan, a blower motor, a wiper motor, anytime you're activating a motor with these relays, When the relay contact comes out, there will be an arc that happens in between the two contacts. Now, some relays will have diodes actually built into the relay to help stop that arc from coming back and help prolong the life of the contacts. But your main failure point on these is going to be an arcing between those contacts, which is going to cause a carbon buildup, which ultimately will make the switch fail. So it'll close, but you won't get that beep. And you won't get any kind of connection. It'll just do that, and then it'll stop, and you won't get anything. It won't actually make continuity. Now, the second failure point is this coil. Now, when you have a relay such as your fuel pump or your air conditioning or something that runs constantly, you have to remember that this coil is going to be energized for the entire time that you are driving your car. So it does generate quite a bit of heat. I don't know if any of you have ever pulled your fuse panel in the engine bay and felt the tops of some of these relays. They can get pretty hot. Now, what can happen is over time, let's just say your car's 10 years old, and this coil overheats and one of these windings break. Well, now you no longer have the magnetic force to pull the switch in, and your relay fails. So those are two common areas. Now, I'm going to give you the most common cars that I know of with relay failures. The number one relay failure that I see is in the early to mid 2000s Hondas, whether it be a Civic, a CR-V, an Accord, basically from like 99 to 2007, 2008-ish. The AC compressor relay fails on these things. And they fail very, very often. The relays are available for about $8 at Napa or Advance Auto or whatever, and can save you hundreds, if not $1,000, in replacing an AC compressor that doesn't need to be replaced. That's the number one. Number two failure that I see is on a lot of GM vehicles. There is a relay that controls power to the ECU, and it fails. And when it fails, it throws all kinds of codes and check engine lights and everything else. And also, too, there is a possibility that the relay can actually pull out accidentally while you're pulling the cover on some of the Chevy vans and things of that nature. But relay failures are always, always, always going to be very hard to figure out unless you know how a relay works. So that's basically the gist of how a relay actually works. Now, as far as troubleshooting them, the easiest way to troubleshoot a relay is to pull it out of your system, pull it out of your fuse box, look at your pin diagram, and now that we know that 87 and 30, see if we can get that to focus. Now that we know that 87 and 30 are our switch pins, one side of 87 or 30 is going to have a positive 12 volts. The other side is going to, go to your device. So if you think you have a bad relay, what you can do is in your fuse box, it's going to look like this. You look at your diagram and you say, okay, that's pin 30 and that's pin 87. You look at how they match up. So now we know that this right here is pin 30, this is 87. Now what you can do to see if your device works is you can grab any small piece of wire. In this case, I'm going to use a little bit of welding wire. Any small piece of wire or a power probe or anything like that, but a small piece of wire is probably the easiest. And you can take it and just jump it out and see if you make any kind of continuity. See, now that we jumped it, technically our fan is running now. So now that we jumped that out, we know our fan is running. But when we plug the relay back in and we activate it, it doesn't run. So now we can kind of say, okay, well, let's replace the relay now and see if it works. You replace the relay, you turn it on, boom, your fans work. So now you know that your relay was bad. Now what you do not want to do is you never want to short across the other two terminals, because one side is always going to have a plus 12 volts from the battery on it. The other side goes directly to your ECU and it is a negative. So if you happen to short the wrong terminals, you could potentially destroy your engine's computer. So don't do that. Make sure that you're finding pins 87 and 30, or in the case of, some of these other relays, like, let me see what the Nissan relay looks like. Yeah, in the Nissan relay, it doesn't show 87, 30, 85, and 86. It has, let's see, come on. It has numbers, 1, 2, 3, and 5. So pins 1 and 2, there you go. Pins 1 and 2 are the coil. Pins 3 and 5 are the switch. So in this case, you would short between pins 3 and 5 to activate whatever it is you're trying to activate and troubleshoot. Now, every single relay, including GM, Ford, Chrysler, all that stuff is going to have a diagram of these relays on it. So you can troubleshoot much easier that way. All right, guys. Now that you have a very basic idea of how a relay works, you'll now be able to troubleshoot a lot better. Relays are not as scary as they seem to be. They are literally nothing more than an electromechanical switch. Now, we won't get into it, but there are some other types of relays. There are solid state relays. There are normally open, normally closed relays. For the most part, in your vehicle, you're going to have what we just showed. Exactly. It's not going to be any different no matter what vehicle you have, how old it is, how new it is. They're all the same thing. This design hasn't changed in probably 40 years. So you don't have to worry about it being any different. All right. Excuse me. Now, on to bigger and better things. Tomorrow night, guys, live, 7 p.m., YouTube live, on YouTube, obviously. Be there. I'm going right now to Instagram, and I am posting a question and answer post. You guys can hit my Instagram, ask me whatever question you want about welding, about car electrics, about mechanical stuff, about anything that has to do with a car, anything that has to do with my life. Let me know what you want to know on the Instagram post, and tomorrow night, 7 p.m., YouTube live, we'll answer those questions for you, and we'll answer whatever else you want to ask in the live show. So go over to my Instagram, link is in the description. Let me know what you guys want to know from me. I've seen a lot of questions in my comments on YouTube, so let's address those. But yes, tomorrow night, Wednesday, 7 p.m., YouTube live. Be there, and I will see you guys there. Thanks for watching this video. Like, comment, subscribe. Let me know what you think, and I will talk to you guys tomorrow afternoon, 7 p.m., YouTube live. Have a good day, everybody.